Okay guys, so this video hopefully will be less than 8 minutes long so we can get through it and post it. During this video, I'm going to give you certain things that I want you to write down so that you can, at the end of this, take a picture and submit that to eLocker either by emailing it to yourself and then posting it, or if you find another way, I'm happy with that. So let's get to it. And additionally, I would suggest you pause this video. I'm not going to post the notes, so you're going to have to write things down, and that's going to be your daily grade. So as you notice here, we have it's chapter 14, and I'm flipping section 5 with 4. So it's going to be 1, 2, 3, and then 5, 4, 6, 7. So in 1883, Arrhenius made the first definition of acids, which you see here. Bronsted Lowry then came along, and these are two different gentlemen, and they each had the same definition, published the same year, but from different labs. And now it becomes about the hydrogen ion. This is going to be our major focus, and the last definition was not until much later, probably in the 1900s, about using electron pairs rather than using hydrogen ions or hydroxides. And Lewis really leads you a lot into organic chemistry, which is really an interesting approach to chemistry, in my opinion. So in 1923, Bronsted and Lowry each discovered this or published this definition. You can read it here. I'm not going to read slides to you, but I would suggest you pause the video and write this down. If I add other things, you'll want to write them in your notes. So when I go to a new slide, pause the video, write it down, then listen to what I have to say about it. So we are going to talk about these two definitions in more depth on the next slide. So what kind of compounds are acids? So this is where you're really going to need to write a lot of things down. So organic acids are things like acetic acid. If you don't remember how to write that formula out from the name, please go look that up and brush up on it. Inorganic acids typically don't include carbon, and they are things like sulfuric acid, hydrochloric acid, perchloric acid. So you need to remember how to name all of those acids. They can have compounds that are positively charged and have a hydrogen ion that can be disassociated. Something like when ammonia absorbs or attaches another hydrogen, now it would be called ammonium, and it is a cation, positively charged, and has a hydrogen that can be disassociated. Another example would be hydronium ions, H3O+. Anions that contain a hydrogen may be something like sulfuric acid that has lost one of its hydrogens, and now it is hydrogen sulfate. It is negatively charged, and it is still an acid, but it is an anion. Bases are compounds that can be ionic compounds that have hydroxides in them. Examples, and please write examples down, like sodium hydroxide, potassium hydroxide, magnesium hydroxide. And magnesium hydroxide actually has 2 OHs that it can donate. Molecules, these would be more of our organic acids like amines. Ammonia is one, urea is another. Anions with or without a hydrogen are bases because they can accept a hydrogen ion. That would be something like sulfate, phosphate, hydrogen phosphate. That gives you examples both with and without hydrogen ions. Please make sure you write those down. Cations we're not going to worry about because there's so few examples and they're kind of beyond the scope of this class. So I do want you on this slide to write down in your notes examples of conjugate bases that form once an acid dissociates. So on the left-hand side, something like hydrochloric acid disassociates, so that would be your arrow, and it gives you hydrogen ions plus Cl minus ions. It could also be an organic acid, something like acetic acid dissociates, giving you acetate plus hydrogen ions. When we're looking at bases that dissociate, they give us a conjugate acid. And when that happens, it would be something like sodium hydroxide dissociates, gives us an OH minus plus sodium ions. Please do that with an organic acid like ammonia. Ammonia, you will have to add water as a reactant. So I'm going to stop here. What I want to see in your notes would be the notes that I just went over at a wickedly fast pace. Please take a photo of your notes and submit those to Plus Portal's eLocker. That will be your grade for Monday, and that date is 3/23. If you have any questions, please email me. This video won't be available until that time. Thanks.